In this episode, we move into one of the most important ideas in responsible artificial intelligence, AI governance. Releasing a system is not the finish line. For many beginners, it is tempting to imagine that once a model goes live and starts producing useful outputs, the hard part is over and the team can simply leave it alone unless something dramatic breaks. Real life does not work that way because AI systems live inside changing environments where data shifts, user behavior changes, business goals evolve, and hidden weaknesses often appear only after the system has been exposed to the messiness of everyday use. That is why mature organizations build rhythms for continuous monitoring, maintenance, updates, and retraining after release instead of treating deployment as a final handoff. The idea of a rhythm matters because this work should not depend on luck, memory, or a panic response after harm appears. It should happen on a steady cadence, with clear responsibilities, clear signals to watch, and clear decisions about when to intervene. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. A helpful way to understand post-release governance is to compare an AI system to a car that has just left the factory. Even if the car passed inspection before sale, responsible ownership still involves checking tires, changing fluids, responding to warning lights, and bringing it in for service when parts were down or road conditions create stress. Nobody would call that a failure of the car's design. It is simply the reality that complex systems interact with the world over time, and that interaction produces wear, drift, and unexpected strain. A released AI system works in a similar way, except its wear is often less visible because it may look normal on the surface while its underlying performance slowly declines. Beginners should pay close attention to that point, because the most dangerous problems are not always sudden crashes. Many of the biggest governance failures happen when a model keeps running, keeps producing outputs, and keeps appearing useful while the quality, fairness, safety, or reliability of those outputs quietly gets worse month after month. Continuous monitoring means regularly observing the behavior of a live AI system so that the organization can tell whether it is still operating within acceptable bounds. That may sound simple, but it includes much more than watching whether the software stays online. The organization may need to monitor output quality, error rates, user complaints, unusual usage patterns, response times, harmful content, bias indicators, security signals, and changes in the kinds of data the system is receiving. Monitoring is therefore not a single dashboard number. It is a structured effort to notice when reality is starting to separate from the conditions under which the system was originally assessed. For a new learner, it helps to think of monitoring as listening for early warning signs rather than waiting for a public scandal or formal incident report. A strong monitoring rhythm lets an organization catch trouble while it is still small enough to understand and correct, instead of discovering months later that the system has been making weak or harmful decisions the whole time. To monitor well, an organization first needs to know what normal looks like. If nobody has defined expected ranges for behavior, then it becomes very hard to tell when a live system is slipping into risky territory. That is why post-release governance often depends on baselines created during testing and early deployment. A baseline might include normal response quality, normal error frequency, expected traffic patterns, acceptable latency, and known limitations in certain contexts. Once those expectations exist, teams can compare current behavior against them and spot unusual changes. Beginners sometimes assume monitoring means checking whether a model is accurate in some abstract way, but in practice the question is usually more specific. Is the system behaving today in a way that is materially different from how it behaved when it was approved for use? And if so, does that difference create risk that needs to be examined, explained, or corrected? What gets monitored should reflect the actual purpose and risk level of the deployment. A low-stakes internal assistant may require a different monitoring profile than a system that influences who gets benefits, who receives services, or how critical work is prioritized. Some organizations focus too narrowly on technical uptime and miss the broader governance picture. A system can be available every day and still be producing misleading, biased, unsafe, or brittle outputs that harm users or degrade trust. That is why monitoring should usually include business outcomes, user experience, and harm-related indicators in addition to technical signals. For beginners, this is a valuable lesson because it shows that AI governance is never only about whether the machine is still running. It is also about whether the system remains fit for purpose, whether people are being affected fairly and safely, and whether the organization can still defend the decision to keep the system active in the environment where it is being used. Maintenance is closely related to monitoring, but it is not the same thing. Monitoring is about observing and detecting, while maintenance is about caring for the deployed system so that it stays dependable over time. Maintenance may involve updating documentation, reviewing logs, fixing integration issues, replacing broken data feeds, improving guardrails, cleaning up dependencies, refining human review processes, or adjusting workflows around the model. A beginner might imagine maintenance as something only engineers do deep inside the software, but operational maintenance often includes policy, process, staffing, and communication work as well. If the system is used by frontline teams, maintenance may involve retraining human reviewers or refreshing guidance for escalation. If the system relies on outside data, maintenance may include checking whether that data source still behaves the way the team assumed it would. The important idea is that live AI systems need active stewardship, and that stewardship extends beyond code into the full environment that makes the system useful and governable. Updates are one of the most visible forms of maintenance, and they can range from minor adjustments to major changes in how the system behaves. An update might fix a bug, improve a prompt pattern, change a data pipeline, adjust safety filters, revise user instructions, or replace an external component that the system depends on. The key governance point is that updates should not be treated as harmless just because they seem small. In complex systems, modest changes can alter output quality, user behavior, or risk patterns in unexpected ways. That is why organizations often need release processes for updates, just as they needed controls for the original deployment. Beginners should understand that every meaningful update is also a governance event, because it may change the evidence base on which the system was originally approved. A team that updates recklessly can unintentionally invalidate earlier testing, create new failure modes, or weaken safeguards that once worked well, all while assuming they are only making harmless improvements. Retraining deserves special attention because many beginners hear the word and assume it is always required or always beneficial. Retraining means giving the model new learning material so that its internal behavior changes based on additional or revised data. Sometimes retraining helps a system stay useful when the world has changed. At other times, retraining can introduce new problems if the new data is poor, biased, inconsistent, or not well matched to the system's purpose. Retraining is therefore not routine maintenance in the same way as patching a dependency or refreshing a knowledge source. It is a deeper intervention that can significantly alter the model's behavior. For a beginner, the main lesson is that retraining should happen for a reason, based on evidence and governance, not simply because time has passed. The organization should know what problem it is trying to solve, what data will support the change, how the revised model will be evaluated, and what risks the retraining process itself might create before deciding to move forward. One reason retraining becomes necessary is drift, which refers to the way reality can move away from the conditions the model was built to handle. Data drift happens when the kind of input arriving in production changes over time. A model trained on one style of customer request, one market condition, or one language pattern may begin receiving something different after policies shift, products change, or users behave in new ways. Concept drift is slightly different because it occurs when the meaning of patterns in the world changes, making old relationships less reliable even if the data still looks somewhat familiar. A fraud pattern, for example, may evolve because attackers adapt. A risk indicator that once pointed toward a real problem may gradually lose value as business practices change. Beginners should learn to see drift as a natural operational reality rather than a sign that the original team was careless. The important governance task is not pretending drift will never happen. It is detecting it early enough and responding carefully enough that the deployed system remains defensible and useful. Good post-release rhythms also depend on people and decision-making, not just technical mechanisms. Someone must own the monitoring process, someone must review the findings, and someone must have authority to decide when maintenance, updates, escalation, or temporary deactivation are necessary. In strong organizations, these responsibilities are clear before trouble appears. Technical teams may watch system behavior, security teams may watch abuse signals, compliance teams may track control obligations, product teams may notice shifting business needs, and operational teams may hear user complaints that reveal emerging weaknesses. What matters is that the organization has a repeatable way to bring those observations together instead of letting them sit in separate silos. Beginners often picture governance as a document rather than a living practice, but released AI requires a working rhythm of meetings, reviews, handoffs, and judgments. Without that rhythm, warning signs may be noticed by individuals but never translated into action, which is one of the most common ways manageable risk turns into preventable harm. The cadence of these activities should match the seriousness of the system and the speed at which its environment changes. Some signals may need near real-time observation, especially for security, safety, or abuse concerns. Other reviews can happen daily, weekly, monthly, or quarterly depending on the stakes, the volume of use, and the likelihood of harmful drift. A beginner should avoid thinking that there is one universal schedule for every AI deployment. A customer service assistant used across millions of interactions may require constant observation and frequent review, while a smaller internal tool may need a lighter rhythm. Still, every meaningful deployment should have some defined cadence rather than relying on vague assumptions that someone will notice if something goes wrong. Post-release governance becomes stronger when organizations decide in advance what they will review, how often they will review it, what thresholds will trigger action, and who is expected to make those decisions when warning signs appear. It is also important to distinguish between obvious incidents and slow degradation. An obvious incident might be a severe outage, a data exposure event, or a widely reported harmful output that forces immediate response. Slow degradation is subtler. The system may become slightly less accurate, slightly more inconsistent, or slightly more biased over time, but not enough on any single day to cause alarm. That slow slide can be just as dangerous because it normalizes weak performance and makes intervention feel less urgent. A team may start excusing strange behavior as isolated noise even when the pattern is growing. For beginners, this distinction matters because many governance failures are not caused by one dramatic breakdown. They are caused by repeated acceptance of small warning signs. Continuous monitoring helps surface those signs, while maintenance, updates, and retraining give the organization tools to respond before degradation becomes institutionalized as normal operating behavior. Several misconceptions can make post-release governance weaker than it should be. One is the belief that strong initial testing removes the need for ongoing monitoring. Another is the idea that user complaints alone are enough to reveal problems. In reality, users often notice only the issues that directly affect them, and some harms remain invisible unless the organization actively looks for them. A third misconception is that retraining automatically improves the system, when in fact it can spread new weaknesses if done carelessly. A fourth is that maintenance is only technical cleanup and has nothing to do with governance. Beginners should push back against all of these ideas. Responsible oversight after deployment means accepting that live AI systems exist in motion, not in a frozen state, and that governance must stay active as long as the system continues influencing real work, real decisions, or real people. A simple example can make these ideas easier to hold together. Imagine an organization deploying an AI writing assistant for customer support staff. At first, the outputs look helpful, polite, and efficient, and the organization is pleased with faster response times. Over the next few months, however, new products are introduced, policy language changes, and customers begin asking more complicated questions. If nobody monitors the system carefully, the assistant may keep sounding confident while gradually giving more incomplete or outdated guidance. Maintenance might require updating knowledge sources, revising guardrails, and retraining staff on when to override the system. An update might improve routing logic or response templates. Retraining might be considered only if evidence shows that the model itself is no longer generalizing well enough to the changed environment. The lesson for beginners is that the system's original usefulness does not guarantee continued readiness. That readiness has to be preserved through deliberate rhythms, not assumed as a permanent property. As we close, the central lesson is that a released AI system should be treated as something that must be watched, cared for, improved, and occasionally corrected as conditions change around it. Continuous monitoring helps the organization see whether the live system still behaves within acceptable bounds. Maintenance keeps the broader operating environment healthy and usable. Updates allow the organization to respond to known issues and changing needs, while retraining offers a deeper adjustment when evidence shows the model itself no longer fits the world it is meant to serve. Together, these activities form a rhythm of stewardship that separates responsible deployment from careless release. For a beginner preparing for the AIGP, that rhythm is one of the clearest signs of mature governance, because it shows that the organization understands a simple truth. The obligation to manage AI does not end when the system goes live. In many ways, that is exactly when the real governance work begins.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit DailyCyber.News.